Hi everyone, welcome to AIML with Sanjay Chouhan. My name is Sanjay Chouhan, and in this video, we'll discuss L2 norm or Euclidean distance. So, here we'll also discuss what is norm and what is distance and how they are related. And then we'll discuss the L2 norm, which is most common norm used in machine learning. And we'll see how norm and distance are related. Basically, they're the same thing. So, we'll discuss in detail the formulas and we'll see examples as well. So let's dive deep. So let's first look into vector dimensions. Okay. We have discussed a vector A, right? This was a vector A, and it was 1, 2. So here we have two components. This is X component and this is the Y component. So we say the vector A is having two dimension. Okay. So vector A is having two dimension. Okay, X and Y, just like this, right? So these were the components for vector A. And we say that it's having two dimension. And we can represent vector A as A belongs to R2. So R represents real number. That means each of the components in the vector A are of real number. And this 2 represent number of components, or this is also known as dimension in case of vector. So, so this is a vector P where we have three components, 1.5, 2, and -5. So we'll say this vector P is belonging to three dimension. So we can write P belongs to R3. Okay, so it's a three dimension. And similarly, we can have n number of dimensions. So here is a vector Q which has n dimensions. So we have components from W1, W2, W3 till Wn. So that means there we are having n number of dimensions. So you can say Q belongs to uh, Rn. Okay, where n is a number and n is the dimension. Okay. In general, you'll see in machine learning, you'll see dimensions of hundreds. So whatever formula that we discuss will be following the two dimension. Okay, we'll be using these examples, A and AB, whatever we have shown earlier. But you can extend the same formula for n number of dimension. So let's look into the formulas. Let's look into norms and distance. Norms is length or magnitude of a vector. So we can say length or magnitude. Both are same thing only. So we know that a vector has a magnitude and direction. And to get the magnitude, we use norm. This will give us the magnitude of the vector. And distance is the distance between two vectors or 2 points, right? Basically, how far these 2 points are, A and B, or how far they are. Okay. And both norms and distance are related. Basically, they are the same thing. We'll see how they are related. So we have seen the vector AB, right? Vector AB, which was vector B minus vector A. This was the calculation for vector AB. So we can use the norm of vector AB, the norm of vector AB. So we use these two lines, two vertical lines on both sides to represent norms. So the norm of vector AB equal to is equal to distance between vector A and or point A and point B. So we know that, right? We had this A point here and B point here. It was 1, 2, plus 4, 5, right? And this was the vector, right? Basically, this is how we calculate the vector AB, the value of vector AB. And this is, if you consider this as a vector, you can use norm to calculate this length. Or if you consider these 2 points separately, then you can use distance between these 2 points to get this distance, right? So, I mean, if you're using a point, then you get the distance. If you are using this vector, you then include the norm. So basically, both of them are same thing. Both of them will give you this length. So that's how they are related. Now let's look into the L2 norm. L2 norm is the most popular norm. You might have seen this in high school mathematics. You might not know is this is a L2 norm. This is default definition for distance, basically the L2 norm or Euclidean distance. So you can say L2 norm or Euclidean distance. This is the default definition of this distance. You might have seen this in high school as well. So we'll first discuss the L2 norm, then we'll see the other kind of norms and distances. So this is how you represent norm, right? You have two vertical lines, okay, on both sides. This is the vector AB, and to represent L2, we have this 2 in the subscript. Okay, to represent L2, we'll have other norms as well. The L2 norm of vector AB is equals to Euclidean distance between vector A and vector B, or Euclidean distance between point A and point B. Okay, so this is what we have seen in the previous slide as well. We'll do the calculation. We'll see the formula here. So the formula for calculating the L2 norm, this is the L2 norm, right? L2 norm for a B vector. The formula is you take the square root of summation of square of each components of the vector. So these are each components of the vector AB. So we have two components, x and y, right? So we square them and we sum them up, and then we take a square root of the whole summation to get the L2 norm of every vector. So here we are using Wi, right? Wi represents each component. So this is like if you have our AB vector was 3, 3, right? So this is W1, first component, second component is W2. We'll see this W notation in machine learning videos as well. So the first component is W1 and second component is W2. When you apply this formula, you have this, right? 3 square plus 3 square, then you take whole square root. So you take the square of each the components, you sum them up, and then take a square root of the whole. So this is square over root of 18, which is equals to 4.24. So that's the value for this. That's the magnitude or the length of this vector AB. Okay. Okay, we have this vector AB. A is at 1, 2, and B is at 4, 5, and the AB vector was 3, 3. Now, we can also use the distance formula to get the same thing. Basically, we need to calculate the distance between point A and point B. So, we are representing distance with ED. ED of A comma B is similar formula. We'll have whole square root of summation of xi minus yi square. So this xi minus yi is equals to wi, right? Because when we do subtraction, we get the AB vector, right? When we do subtraction of vector B and vector A, we get the AB vector. So this will give us the yi, the same as yi, and we take the square of this difference and then sum them up. Then we take the whole square root of the whole thing. Um, here, I mean here the we can use yi minus xi or xi minus yi. It doesn't make any difference because we are taking square, right? So if you say that okay, here in this calculation, right, we'll have minus 3, but in AB we have 3, but it doesn't make a difference because anyway we'll take a square, so it will be positive number. Okay, so let's see. So basically in the A component we have 1, and in the in the vector A we have 1, 2, and in the vector B we have 4, 5. So we take the difference of first component, that is 1 and 4. So 1 minus 4 squared plus difference of the second component is 2 minus 5. So 2 minus 5 square Then we take the square root of the whole thing. So this will be minus 3 square plus minus 3 square, which will be 9 plus 9, that is 18. So square root of 18 is 4.24, which is same as what we have seen for L2 norm. So we know that as we have seen already, the L2 norm of AB vector is same as Euclidean distance between point A and point B. So let's do one more calculation of L2 norm and Euclidean distance. So we have this vector A, right? We have seen this vector A, which is also OA, right? It's same as OA. We have seen this. The L2 norm of vector A is 1 square plus 2 square, then we take the square root of whole thing. So the coordinate for vector A was, the components are like 1, 2. Right? So A was 1, 2. So we take square of this, we then take a square root. So it's square root of 5. So this is the L2 norm of vector A. And the distance, the Euclidean distance is going to be from origin, right? Because vector A is start at the origin and it goes till the point A. So we need to take the distance between the origin and point A. So if you apply the formula, it will be like this: 1 minus 0 square plus 2 minus 0 square, and you take the square root of the whole thing. 0, 0 is the coordinate for the origin, right? And 1, 2 are the coordinate for the vector A, or the point coordinate point A. So we are getting the same thing, square root of 5. Thanks for watching. If you have any comment or if you have any queries, please comment, and please like and subscribe. Thanks again. See you next time. Bye.